Hello viewer, my sincere greetings to you. Welcome to the cast on artificial intelligence and big data. In this cast, we will discuss the intricacies of physical internet and try to understand the basics of PI. By end of this cast, we will have a better understanding of the given points. So starting with the first one, let us detail on the concept of physical internet. The current global logistics and supply chain management practices of transporting, sorting, and handling physical freight are unsustainable in the long run from economic, environmental, and social perspectives. Researchers specify specific symptoms of the unsustainable global logistics and SCM practices that constitute the worldwide global logistics sustainability grand challenge. If you see, using the latest improvements in information sharing, interconnectivity, information technology, data mining, big data, and data analytics, it is possible to develop new logistics and SCM practices that are sustainable in the long run. The physical internet is a new boundary spanning area of research and practice that seeks to address this grand challenge. The aim of PI is to optimize logistics and SCM processes so as to create more efficient, effective, and sustainable supply chains, which may lead to innovations in supply chain models and strategies. The PI is described as a global logistics system based on the interconnection of logistics networks by a standardized set of collaboration protocols, modular containers, and smart interfaces for increased efficiency and sustainability. PI could be defined as a comprehensive and measurable supply chain framework which is based on a network of physical components. These components are standardized as well as optimized and exchange information to improve the effectiveness, efficiency, and sustainability of supply chain management operations. The PI is a holistic concept that merges numerous relevant areas of logistics and supply chain management research with the promise of disrupting current logistics and SCM practices. These areas include sustainability, effectiveness, and efficiency of global value chains and information flows, as well as horizontal and vertical collaboration. For example, if you see, the modular containers are world standard smart, eco-friendly, and modular, aiming to transform the existing transportation, handling, and storage of cargo containers through smart, sustainable, and seamless automation and human handling. The PI hubs enable efficient unimodal and multimodal dispatching and routing of modular containers in an open logistics network via consolidation of loads, which in turn lowers inventory and logistics systems costs. So moving to the next point of discussion, let us see what is latest in physical internet. Considering the growing number of PI researchers and the globally increasing investments in PI related projects, the PI is rapidly gaining relevance in both academic and practitioner circles. There are three major PI related goals. Establish the landscape by elaborating, developing, and demonstrating a PI enabled interconnected logistics vision and its characteristic. Provide simulation and field-based proof of concept by gradually implementing and testing key functions of PI-enabled interconnected logistics. And the third one is develop a comprehensive strategy for research, innovation, and market deployment of logistics and supply chain management innovations throughout the world. The PI draws on concepts from numerous different technologies and areas of research. These includes the Internet of Things for interconnectedness of logistics networks and the key performance indicators for continuous measurement and improvement. The PI has the potential to become a disruptive innovation that inspires vast multidisciplinary collaboration to solve several pressing social and business problems by revolutionizing extent, logistics, and SCM practices. The PI is an emerging concept that currently underperforms in comparison to the existing logistics and SCM practices. But it has the potential to radically transform the way physical products are being handled, transported, and stored. These changes could greatly influence the environment, economy, and society. As the last point here says, the PI is still a relatively new idea that is poorly understood. Hereby, we will look back into the origin of PI as a concept and explore its background. The term physical internet was first used in a 2006 headline of the British popular press magazine The Economist, which contained a survey of logistics and a variety of mainstream supply chain articles. In the subsequent years, this publication inspired a team of researchers to explore the possibility of organizing the flow of physical goods in a manner similar to the data flow on the digital internet, leading to the emergence of the physical internet. Let us also explore why the business world is so keen on this concept and why there is need of any such concept. The PI was conceptualized as a response to the inefficiencies and unsustainability of current logistics and SCM practices. There are 13 identified issues that make the current logistics practices unsustainable. Limited space utilization for road, rail, sea, and air transport. Empty travel being the norm rather than the exception where the carriers had been plying without the optimal load, leading to loss of resource. Poor working conditions for truck drivers as their total traveling time could not be calculated. Products sitting idle in the warehouse for getting transported, since the inventory of the carriers is not available in real time. Inefficiency of product distribution as the optimal path for transportation could not be known. Inefficient use of product and storage facilities where the production and supply are not in sync, leading the product sitting idle and the warehouses facilities are underutilized or overutilized. Mediocre coordination within distributed networks as the transporters are not connected and the delivery of consignments could not be planned efficiently. High inefficiency of multimodal transportation, where in the collaboration among various modes of transportation is very limited, leading to unplanned delays in the supply of goods. Dysfunctional city logistics, as there are specific guidelines for a specific mode of transport inside the towns and cities due to resident population. Inefficient cross-docking operations as the unloading and loading of consignments could not be carried out efficiently. Low network security and robustness for the goods and transporters since the standard protocols in SCM are missing. Difficulty justifying the use of IT in supply chains, as in current times, the effective use of IT infrastructure is very limited due to lack of knowledge among the transporters. And the last point is that there is a limited innovation opportunities in current times. This is due to the fact that the businesses are happy carrying out the logistics in the traditional way and no new working methods are incorporated. In the light of these issues, the global logistics sustainability grand challenge could be improved through the 13-point principles that are given here. It is suggested to explore how to apply each of these principles respectively to achieve more sustainable supply chains. We are now moving into the last section of this session and will try to explore the prime objectives and constituents of physical internet. Keeping in view the discussion till now, accordingly, it could be said that PI is an open global logistics system founded on physical, digital, and operational interconnectivity through encapsulation, interfaces, and protocols. It could be considered as a perpetually evolving system driven by technological, infrastructural, and business innovation. The main PI objective is to transform the way physical objects are handled, moved, stored, realized, supplied, and used, aiming towards global logistics efficiency and sustainability. The PI aims to organize the transportation of physical goods in a manner similar to the way in which data packages are moved on the digital internet. By sharing resources such as vehicles and data and designing transit centers which enable seamless interoperability, the transportation of goods will be optimized with regard to cost, speed, efficiency, and sustainability. To achieve this optimization, the PI sets common and universally agreed upon standards and protocols to facilitate horizontal and vertical cooperation between organizations. It is crucial to distinguish clearly between the PI and its constituents. The PI can be seen as an application of the IoT that describes a network of physical objects embedded with technology to collect and exchange data. Similarly, the PI drives the creation of innovative delivery channels for services, whether in the area of data exchange or logistics, both of which are commonly included under the term Internet of Services. Additionally, a PI could be considered as an application of cloud computing that includes the practice of using a network of remote internet servers rather than a local server or personal computer to store, manage, and process data. Accordingly, a PI is an open concept that embraces novel technologies with the aim of disrupting the current logistics and SCM practices to design more efficient and effective supply chains. So what constitutes a physical internet? As noted till now, the PI does not directly manipulate physical goods, but rather manipulates and manages the shipping containers that store goods. It is just like how the digital internet packets store embedded data. For the PI to become full-fledged, numerous elements need to be coordinated, including physical objects such as PI modular containers or PI transit centers, and more abstract concepts such as legislation and business models. However, if you see previous studies which focused running simulations with a small number of actors in dedicated industries have shown that considerable gains can be achieved through the application of the PI even if it is incomplete. The simulated models use data representing the flow of goods from the fast-moving consumer goods, that's FMCG industry in France, to test various transportation protocols and scenarios. The simulations concluded that the PI is very efficient within the FMCG supply networks of large retailers. It reported positive effects on greenhouse gas emission, cost, lead time, and travel delivery time. Similarly, another model reported the findings of an exploration project in Canada. Here, the simulations revealed various positive effects of the PI, including increased fill volumes, energy savings, decreased transportation costs, and reduction in the total logistic costs. So, at the end, it is well understood now that the physical internet is an emerging logistics and supply chain management concept that draws on different technologies with the purpose of revolutionizing existing logistics and SCM practices. Alright, that's going to do for this video on artificial intelligence and big data covering the concept of physical internet. I hope you find it useful. Remain connected for more of such content on information technology and information systems. And just remember that creativity is inventing, experimenting, growing, taking risks, breaking rules, making mistakes, learning from the mistakes, and having fun. Always, always be creative. Thanks for watching.